Hello, and welcome back to Educator.com and this series on AP Computer Science. The topic of today's lesson is inheritance and polymorphism. Inheritance and polymorphism are powerful features of Java, being an object-oriented language. And they're also very important concepts to understand for the AP Computer Science exam. You can definitely expect to see questions about inheritance and polymorphism on your exam, both multiple choice questions and the fact that you'll be expected to understand and implement inheritance and polymorphism correctly on some of your free response answers as well. So let's take a look. Today we'll be talking about inheritance and the notions of subclasses and superclasses that are really the heart of how inheritance works. We'll talk about class hierarchies and how you can have multiple levels of classes that inherit from other classes. We'll then talk about abstract classes, which are a special type of class. We'll talk about polymorphism and how that works and why that's beneficial. And finally, we'll talk about interfaces. Inheritance is the method that allows a programmer to specify that one class extends another class. And in Java, this is written with the keyword extends. If I have a new class called student, and I say that it extends another existing class called person, what that means is that student inherits all the attributes and functionality that's already defined in the class person. Student can then change or add to the functionality that is defined in the class that it's extending, which in this case is person. The class that extends another class is called a subclass. So in this case, student would be the subclass. The class that is being extended is called a superclass. In this example, that is the person class that is acting as the superclass. This implements what's known as the is-a relationship between student and person. We say that student is a person. Student has all the attributes and capabilities that a person does, plus more. It is a one-directional relationship. So a student is a person, but a person is not necessarily a student. A person may be a person without being a student. They may be something else. So it is definitely a one-directional relationship where the subclass student inherits attributes and functionality from person, but the relationship does not go the other way. Person does not get anything from student. Objects of a subclass inherit the data type of the superclass. Because of the is-a relationship, where student is a person, you can pass a subclass to any constructor or method that expects the superclass. So for example, if I continue with the same example as before, and I have student extends person. So student is the subclass of person. Student is a person. And I have a method, print mailing label, that's defined somewhere else outside of both the student and person classes. And print mailing label takes a person, P, an object of type person, as its parameter. And it retrieves the data fields from that person necessary to print a mailing label. I can declare a student, S, call the constructor to create a new student, and I can actually pass S to the print mailing label method. Even though print mailing label accepts a person and S is a student, student is a subclass of person. So student can actually act as a person, and this is perfectly valid in Java, to pass a subclass to a method that expects the superclass. That will work just fine. A subclass also inherits all the public methods and all the public variables of the superclass. So in my superclass person, I probably have the name of a person, and I may have a getName method that returns the name. Because name is a private string, I want to have an accessor that gets the name and returns it to wherever in the code is using this person. Then I have student that extends person, so student is a subclass of the superclass person. I declare a student S, call the constructor, and then I use the getName method, which is defined in the superclass person. I can call that on an object S of the type student, which is the subclass. So even though I did not define a getName method on student, it inherited the getName method from the superclass. And this is perfectly okay. A subclass, however, does not inherit any private methods or variables of the superclass. So in the superclass person, the string called name is a private variable. So it would be an error for me to try to reference the name attribute of an object S. S is a student. Student does not have a name attribute. It inherits the name, it inherits the attributes of the superclass person. But because name is a private string, it does not inherit the name. So something that is calling, or that is using the object S of type student does not have access to a private variable from the student superclass called person. This would generate an error if you attempted to do that.